I just received some of the boards for my upcoming project and I thought I should give you guys a quick look and just generally give you a preview of what's to come on the channel. JLCPCB graciously provided all these boards for free, so a huge thanks to them. I have been using JLCPCB for quite some time now and they definitely get my recommendation. They produce really high quality PCBs for unbeatable prices. Their customer service is also top notch. They also provide all the information and tools you would ever need to quickly get your prototype boards made. I'll link to their website in the description. You guys should consider checking them out. So, I'll be going through the boards one after the other while also giving you guys a bit of information about the project that I designed the boards for. I have a total of 9 boards here and I'm really excited to show you guys. So, let's get to it. This is really exciting. The first thing I can see is this key holder. It says Hello JLCPCB and it has a cute little dog on it. That's nice. Alright, so the first bird I have here is maybe I should just take out all the birds first and go through them one by one. As you can see, I ordered all the birds with black solder mask. I'm a real big fan of black. On PCBs, I mean. Alright, so I have all the boards out now. I'm not really sure which one to start with, so maybe I just start with the one I'm most excited about. And that's this board right here. This is one of the 4-layer PCBs I have here. We'll get to the other one in a moment. Alright, I'm just going to take one out and show you guys. As you can see, this is a very small board, but it does have a lot going on. So, okay, this is the main board for a 3D printed dial I designed last year, or I should say the version 2 of a 3D printed dial I designed last year. I have to say, I really like how this board turned out. It looks really, really nice. And it looks like all the features I designed in came out nicely. So that's really cool. I'll show you guys what this board is really about later on, but as you can see on the back here, it says Amsville Dial V2 main board. So this is the main board for one of the projects I talked about, which is the version 2 of a 3D printed dial I designed last year. All in all, I think it looks pretty good. Let's check out the next one. Alright, so this is the second 4-layer PCB. So I'm just going to rip it open and we'll see what we have. This is also a really small board. And these 4-layer boards are all impedance matched from JLCPCB. This one also turned out really nice, exactly as I designed it, so that's good. The text on the back didn't come out quite as clear as the first one. Although to be fair, the text on this board is way smaller than the other one, so I think it's still good. It's still perfectly readable, just not as clear as the first one. This board is also related to the first board, that is the dial project. And as you can see, the text on the back says Amsville Dial V2 wireless adapter. I'm sure from the little information I've given, you guys can already guess where this project is going. Alright, let's move on to the next board. Alright, this is also part of the same project, which is the dial, of course. And I'm just gonna open it up too. Alright, here we have a slightly bigger board. You'll be able to see what all these boards do once I make the actual video about the project. So stay tuned for that, I guess. Alright, so if I turn the board over, you can see the component side. And for this board, it was really important to make sure all the texts are clear, because the texts are showing connection points. So I think it came out really nicely. All the texts are super clear and readable, so that's nice. There was actually an error with this PCB when I first submitted it, and it was a pretty big error too. But I reached out to JLCPCB and they gave me a chance to re-upload the Gerber files, so that's nice. And taking a look at the board, I can see the changes reflected, so that's really nice. Alright, if you take a look at the back of this board, it says Amsoil Dial V2 USB board. So I think that's pretty self-explanatory. Alright, let's move on to the next one. I think this board is for another project. This board also belongs to that same project, so I'll just put them together for now. Alright, this is another board relating to the first project, so let's open it up. Alright, this one turned out really nice too. And as you can see, there's really not much going on with the board, component wise that is. That's because the board is more mechanical than electrical. Again, these are all things you see when I actually make the videos on the project. So again, stay tuned for that. Alright, so this one says on the back, Amsoil Dial V2 Sec Enc board. What that means is secondary encoder board. So again, one of those self-explanatory boards. I'm really excited about this project, so I'm really looking forward to sharing them with you. Alright, this next board is also related to the first project, so I think that makes 5 boards now. So that goes to show just how big the Amsoil Dial project is going to be, or at least I hope it's going to be big. Fingers crossed. Right, so the board I have here is a mechanical key. It's a mechanical keyboard. What I mean is it's supposed to hold mechanical keys. Alright, so I have here some Gateron clear switches. Really nice soft switches. Let's see if it fits. And it looks like it does. It does quite well actually. That's really nice. The board should hold 5 of this. Alright, so I'm just going to put that aside and move on to the next board. Alright, so I should have one more board relating to the same project, and I think that's this one. Yeah, it is. Alright, so as you might have guessed from the silk screen on this board, this is a capacitive touch board, and it has a bunch of holes around it. And I'm sure some of you guys might already have an idea of why the holes are there, but I won't say anything for now. You will see what they are meant for when I make the actual video on the project. But this is also a really nicely made board. It came out exactly as I designed, so no complaints here at all. Alright, so all the boards we've taken a look at so far all belong to the same project, and that's the version 2 of the dial I mentioned earlier. I'll show you guys my test setup for that project later on in the video, but for now let's just move on to the next board. Alright, this next board is related to just its own project, so let me open this one next. Alright, this is another tiny board, really small, and this particular board was a real pain to route, mostly because I wanted to keep the board as small as possible while also breaking out all the pins on the high C. But came out nicely, exactly as designed, so pretty nice, pretty nice. Alright, if we take a look at the back here, it says USB digital audio. So that's the function for this board. It's a USB sound card based on the CM6350, I guess. It's a chip from C-Media. I'm just trying it out to see if it works. Actually, I designed this board to go along with a board I designed a while back, which is this board right here. As you can see, this is an audio amplifier board, but I've been unable to get it to work, so I designed the USB board to hopefully finally get it to do something. So fingers crossed for that. Let's hope it works out. And if it does, I should be making a video on it too. So also one more thing to look forward to. Alright, so let's take a look at the final project. Anyway, this last project is somewhat related to the first project, so it's separate but related, and you see what I mean in a minute. Alright, so as you can see, this board is a perfect circle and it's a magnetic rotary encoder. For those of you that don't really know what I'm talking about, when I say magnetic rotary encoder, this is a rotary encoding method I developed last year. It's the same rotary encoding that's on the DAR project. So what this board is a standalone version of that rotary encoding method. And if you read the text on the back here, it says magnetic rotary encoder with an addressable LED ring and capacitive touch. And right below that it says Res 60. Now Res stands for resolution. So the base resolution for this rotary encoder is 60, but it does go as high as 500. I'll dive into more details in the video I make about this board, so I'll be going through in details on how to use the board with different Arduino boards. Alright, so this is the last board, and obviously it's just another capacitive touch board, and this board goes with the previous board we just looked at. That's the capacitive touch part for the rotary encoder board. There isn't much to this board, it's just a plain board with a little header in the middle. I do wish this identifying text was placed at the back, but it's fine. Don't care too much about it. Most of the boards you've seen will all end up inside 3D prints, so they won't really be visible. So I'm not too bothered about how they look. Right now, so let's quickly take a look at the stencil. So I ordered the stencil for some of the boards you've just seen, just the ones that need stencil. Right, so there you have the stencil. Apologies for the reflection. The stencil is really reflective. Anyways, I have I think I have the stencil for 8 boards here, so there's really not much to say about this. It's just a stencil. I'm just going to pack this aside and move on to showing you my test setup for the first couple of boards we looked at. So let's do that. Alright, so here I have my little setup for testing the version 2 of the Amsville dial. As you can see, we have some mechanical parts connected to some modules. So I used this setup to test the concept and make sure all the parts I wanted to include with the project work well together. So, and as of right now, the code that controls all of this is pretty much done. So this is a confirmed working system. Alright, so in the center there, I have a SAMD21 board, which is the main brain for this entire system. And the board is connected to this NRF24 module. And I also have this MPU 6050 module connected. This is an accelerometer and gyroscope module. And over here is an implementation of the magnetic rotary encoding that I spoke about earlier. As you can see, it has a bunch of magnets on it. Again, I will be describing this rotary encoding method in full details in the actual video, so just look forward to that. It should be a fun video. So over here I have a little vibration motor, which was part of the hardware features of the version 1 for the dial, and it's also present in the version 2. So, and over here I have the capacitive touchpad. On the second breadboard I have an Atmega 32U4 board connected to another NRF24 module. So the main board here is meant to communicate with the 32U4 via the NRF24. It's a really exciting project, and you guys should really look forward to it. So everything you're seeing on this little test setup is what's implemented on this board. So over here I have the NRF24 circuit, and here right in the center of the board I have the MPU 6050. That's the accelerometer and gyroscope chip. And then over here is the SAMD21G chip. And to the side I have a bunch of breakout pins. So these pins are how this main board will communicate with all the other boards associated with this project. So the second board is a replica of the setup on this second breadboard. So on one side I have the NRF24 circuit, and if I flip it over I have the Atmega 32U4. So I also decided to break out some of the pins, just cause. Alright, so there you have it. Just a quick preview of what's to come.